Hi friends, welcome to Civil Architecture Tutorials. Today we discuss regarding the difference between flat slab system and conventional slab system. I already did a video regarding the flat slab system. So now this video will focus only the difference between the flat slab system and the conventional slab system. So let us begin. I will describe around 21 points the differences between flat and conventional system. Okay, so the first point is regarding the system means the flat slab system. We know that we have got only slab and the column. Of course there is a drop panel, but there is no beam in it. But when it goes to the conventional system, we have got slab, beam, and then columns. So that is system. The second one is the load transfer. The load in the flat slab system is transferred from the slab directly to the column. But while in the conventional system, the load from the slab is first transferred to the beam, and from the beam it is transferred to the column. So that is the difference from conventional and slab system. The second difference. The third difference is the weight. The weight of the flat slab system is comparatively low when it's compared to the weight of the conventional slab system. And then fourth is live load. The live load is shall not exceed 3 times the load design dead load. That is, in flat system, there is a design dead load for every, even if it is a conventional system or a flat system. The structural engineer, the consultant will define how much will be the dead load, how much will be the live load. All these things will be defined. So especially in the case of a flat slab system, the live load should not exceed 3 times the designed dead load, but it has no connection with the live load or dead load in a conventional slab system, because it can exceed, doesn't matter. It has no connection with the design dead load in conventional slab system. So, and in regarding the fifth point, the thickness of the slab in a flat slab system is comparatively large when compared to the conventional slab system, because as you know, it has got 2 layers. The first top layer and second bottom layer is got mesh, and in between chair is there. So because of this system, the thickness will always go at a higher depth when compared to the conventional system. And then the sixth point is minimum thickness of slab. The minimum thickness of flat slab is 125 millimeter, and while for the conventional system it will be very less. When compared to the flat slab system, it will be 100 mm. So minimum for flat slab is 125 mm, for conventional is 100 mm. And then regarding the height of ceilings, we will have a clear ceiling height in flat system, and because of that people usually go for this thing. That is the main advantage of a flat slab system. That is, we don't need any false ceiling for that. We will get a clear height from the floor to the top. While in conventional system which includes the beams, we will never get a clear system, because there is always some kind of beams coming in between, and it will be a hindrance to that particular system. Because of that, we are going for false ceiling. So there is no clear ceiling height in conventional system, but we have got a clear height in flat system. And the 8th point is drop panel. As we know, all the flat slab system will always come with a drop panel. Without drop panel, it will be a failure, because we are not providing any beams. So in order to avoid the puncturing shear, we need to provide the drop panel in flat slab system, but there is no drop panel system in the conventional system. And the 9th point is the ratio of longer span to shorter span. The ratio of longer span to shorter span should not be more than 2.2 in flat slab system. It should not be more than 2.2, but it has no connection in the conventional flat system. We don't have to look into whether the ratio is more than 2.2 or less than 2.2 in conventional slab system. And the 10th point is the story height. The story height will be minimum. Means we don't have to give very high story height in flat slab system, because we don't have any hindrance inside. Means there is no beam inside. So when the beam is coming, then we need to increase the height of the story in conventional system, because of the depth of the beam, we need to give more clear space from the beam to the floor. So for that, the story height should be increased in conventional system, but in the case of flat system, we don't need to provide such things. The story height will be minimum when compared to the conventional flat system. And regarding the services like sprinkler and piping, it is very easy to provide the sprinkler system and piping system in a flat slab system when compared to the conventional system. You know the difference? Difference is that there is a beam. So if there is a beam, you know with the piping how to go just like that. May how to give some conduit inside it, but it is not advisable to give conduits inside the beam. It have to go around the beam, something like that, or we have to adjust in according to the beam. So that is a problem when the piping and sprinkler system comes, when the fire system is coming on the top. All these and the electrical conduits will be a problem in beam system, the conventional system. But in flat system, it is comparatively very easy because there is no presence of any beam. You can do in whatever way you can do, the work will be easier. So then regarding the illuminations also, comparatively better without beams. That is, in the flat system there is no beams, so the illumination level will be high because there is nothing to hide. If you put a light in the center of a roof, and if there is no beam, that means that light can travel to a long distance. When there is a beam, it will be a shadow, it will prevent the light to travel. So illumination level is better in flat system and compared to conventional system. And same as the acoustic treatment too. Acoustic treatment also depends upon whatever obstruction in between there, it will reduce the acoustic system. But if it is in the flat system, since there is not much obstruction, it will be easier when compared to the conventional system. Acoustic treatment is far easier. And regarding the reinforcement, like I said before, there is two layer of reinforcement. That is on top a mesh, there will be a mesh, and bottom there will be a mesh, in between there will be chair in the flat slab system, but it is not present in the conventional layer. They are conventional slab system, they are using only single layer. Then regarding the earthquake resistance is less in flat slab system because it is less flexible, but in the conventional system it is more resistant to the earthquake, since that the reinforcement will be more flexible to earthquake. So in regarding the earthquake, it is always better to go for conventional system. And the appearance, as you know, appearance is far better in flat slab system when comparing the conventional system because there is the absence of beams. And then the need for construction, at least 3 continuous span in each direction are needed in flat slab system. To make it as a flat slab system, there should be at least 3 continuous span in each direction. For in the conventional system, even single slab is also possible, which is not possible in flat slab system. It is a necessity that it needs 3 continuous span in each direction. So that's why that is one of the important point by which we cannot go for flat slab system in all the buildings. It should be big enough to do all these things. Continuous span should be there, at least 3 continuous span should be there in each direction. And this 18th point is the quantity of formwork will be always less in flat slab system when compared to the conventional slab system. As there is a beam, always the formwork quantity will be very high. That is, you have to cover up the U-shaped area of the beam wall area with the formwork, which is totally absent in flat slab system. Likewise, the time provided for construction, because of all these things, the formwork is not there, and because of the formwork is not there for the beams, when the beams are absent, we don't need to go for the reinforcement of the beams, and no need to do the formwork of the beams. So the construction time, the time period for construction will be automatically less for the flat slab system when compared to the conventional slab system. And the 20th point is cost of formwork. Cost of formwork is simple. Whatever be formwork only for this slab system and for the drop panel and for the column. So when comparing to the conventional system, the cost of formwork will be less because the material needed is also less when compared to the conventional slab system. Then the last point, the cost of structure is more economical in flat slab system, since because the formwork and material is very less in the flat slab system. Of course, it will be economical when compared to the conventional system. And if we are going for a basement, ground and +3 G+3 building, it shows that it is comparatively 16% less costlier than the conventional system. So when compared to a flat slab system, conventional slab system will be more expensive. So I think you understand some of the differences between flat slab system and conventional slab system by this video. I will come with a new video with a new subject. Till then, goodbye. Please subscribe, share and like my channel. Thank you very much.